So I've been asked numerous times about the circuit for this particular um, solid state Tesla setup. It's not a very complicated circuit at all, but there's a couple of things I could do with telling you about it, and that is, one, you could, if you wanted to, there's a 4.7k resistor goes across here. Now you're going to have to fill in some of your own bits and pieces on this. Like on the actual circuit that I'm going to show you in a minute, I've not put the values down. And the reason why I haven't put the values down is because I'm going to tell you the values now, and you can play around with these if you want to. I have played around with the values, and there you can see there's a variable resistor there, 10k pop, but I've found that it's best using a 4.7 on this particular setup. Now every setup's going to be slightly different. I've just noticed that somebody's asked me to give them the complete breakdown, the formulas for how you do this. Now I'm not going to do that. You can look up the formulas for this. If you're that technically minded with it, then you can look up the formulas for this and get it from the experts. I'm not an expert, I'm a play with electronics at home guy, and most of mine is just done through pure experimentation, and that is practical experimentation with the circuits. Okay, so that I would suggest for a lot of you guys that you should probably do the same sort of thing. So rather than sort of try and explain where the connections are on here, it's just simple enough. I'll show you the circuit in a minute. I'm just going to show you that it sort of still works. I'm not going to, let's just turn this up. I'm not going to demonstrate it at full power. I've got too many devices in the vicinity of this that will be sensitive to it, and I don't want to do that. So as you can see, the circuit works. Now with this one, I have noticed, I watched a few of these videos on YouTube, and I noticed that sometimes if you put the primary the wrong way round, let's say, it doesn't work. But with this one, it doesn't matter. It doesn't matter either, which will go against some of the formulas. It doesn't matter which way the coil's wound. Now on this one you can't really tell that easy, but on this one you can see that the coil goes around and it goes one lower and then ends up coming out the bottom here. This one works the other way, so it starts from the bottom and brings itself up to the top. But I suppose and if you swap this over, it's going to be exactly the same thing. And that's the thing to note with this, is if you turn it over, it's still wound the same way, the same as what this is, even though these two do go in different ways. But I've tried them on the circuit and they both work fine. It's depending on how many turns you do on this, like the more turns you do, the more voltage you're going to need. The less turns you do, the more current it will take, but less voltage that you need. Okay, now this is the resistor that's normally in place here, which is a 4.7k, and I find that this works very well, and in actual fact the way that this is set up, it works at 4.7 with a margin of error for these particular parts, but it is pretty much the same. Now you could, if you wanted to, start playing around with the resistor and drop it down to 1k, but you're going to be drawing a lot more current through the system, and it's not going to be as well balanced, because to get the breakouts that I got, and I'll put the links for the in the description for a couple of the videos, for the ones that you guys have been asking me several times about this particular circuit. And to be honest with you, I have pointed out the circuit to quite a few people, and it's a very, very simple circuit, but I'll put the links in so you can actually see it working at full power. But what I was going to say was, yeah, you can drop the input, because what you're doing is you're taking the voltage that comes in and you're just regulating that current with this particular resistor before it goes into the LED here. But you can drop it down and you'll get a better result at different voltages. But if you want to be able to take it up to the higher voltage and have a real good result, 4.7k, play around with it. This is what I say to you, because your setup is not going to be the same as mine. You can play around with it. And if you want to know about this particular coil, this coil works different to other coils that I've got. I can put a bigger coil on here and it doesn't work quite as well as what this coil does. I could put a slightly smaller coil on here and I don't need as much power, and that works really well, but it still just doesn't work as well as what this particular coil does. Now, this coil has about 850 turns on it of, I think it's 0.28 magnet wire. It's using a bit of PVC drainage pipe. I think that's 2.5 inches, something like that, 2.75 inches, whatever that is. But the key part about the drainage pipe is use the white pipe. Don't use the black pipes because it's got carbon in it, and that's going to affect the way this thing works. And the transistors tip 35Cs, and you got your couple of resistors here which are 0.33 ohms each resistor going off to each emitter. Okay, and that's it. That's all there is really to it. This complicated part here, the way it looks is yeah, it's, you know, it looks a bit messy there, a bit complicated, but it's just easy for me. And I'd suggest to you as well that if you don't want to be soldering, resoldering, get yourself a bit of one of these strips, because then you can chop and change by the turning of a screw. Much easier. You'll end up being able to experiment with a lot more components in a lot shorter amount of time, and that's the main reason why I did mine like this. So let's have a look at the circuit. Now, here it is. Look at that. How simple can you get? That's it, that's all there is to it. I've not put any values in there because there's no point me trying to tell you, hey, you did a certain amount of turns. If you look at the videos that I've made of this circuit before, you'll see that I try different coils, and as I've just explained, that you can wind it clockwise, counterclockwise. There is differences, but play around with it. Make two, one clockwise, one counterclockwise, and just try the differences for yourself. See what you, how it works out for you. So here you can see this is where we're going to apply the power. That's the negative, and that's it. You can see the two transistors there. You can see the two resistors coming off the emitters, and the resistor and the LED. Not a very complicated circuit whatsoever, and that's what I did it for. A lot of people have suggested, hey, why don't you try doing this, try doing that, but that's not what I wanted to do. I just wanted to build something that worked pretty good, but as basic and as simple as possible. For me, not to try and teach anybody anything. This is just about something I was doing, and I'm basically just logging the things I was doing on YouTube, by making the videos, putting them up on YouTube, sharing them, see if I get any feedback of bits and pieces, but I didn't want to overcomplicate things. We told, try interrupters and all this sort of thing, but I haven't got around to doing any of that yet. But this is the circuit, so if you want the circuit, there it is. Pause the video, whatever, and you can see this is the main coil. That's just suggesting the breakout. It connects in to the connection between the resistor and the LED. And it goes off to the base of the transistors. Couldn't be any more simple. So, I mean, at the minute, look, that's using 200 milliwatts, 200 milliamps at 17 volts. Although that's not the greatest breakout, but I've not got any cooling on this or anything like that. So, that's just the way it is. It's not got a top. Normally I stick a top plate on the top, don't I? but that's not on there either. It's just showing you the circuit works, and this is really what people were asking me for. So this is what I'm just showing you. This is not a demonstration of the circuit working really, it's just showing you this. And I hope that's satisfied the guys out there that were asking for it. Okay, I'll see you in the next one.